Hello everyone, I'm Alfian and today we are going to solve the LeetCode challenge on the challenge number 5 and the medium difficulty called the longest palindromic substring. And for this particular challenge, we are using the TypeScript as our language to solve this. And the function says longest palindrome takes one parameter called the s in the form of string, and the expected output is also in the form of string. And if you want to use something else other than TypeScript, then go ahead and encourage you to do so. And for this particular challenge, given a string s, return the longest palindromic substring in s parameter from the s parameter. Let's say we have the example one right here, the input s, which is the B, A, and D, and as we know, the palindromic, that a word that can be reversed from the front and or from the back, and we have B, A, and B right here. If we reverse the B from the back, we also got the B, A, and B, and it's also the same thing goes to the A, B, and A. And if you reverse this, we also get the A, B, and A. But then since both have the length of 3 characters, then of course we are only returning the first one as our answer. And for the example number 2 right here, we have C, B, B, and D. Since it is an even composition of S string right here, we are only returning the B and B right here on the index number 1 and index number 2 from the string composition right here. And it is also counted as the palindrome substring. And we have the constraint of at least one word inclusive with the length of the string, and it is also inclusive with the length of the string. The string itself has at maximum of 1000 letters, and the S consists only digits and English letters, which means it's only containing either A to Z or 0 to 9. And for this hint right here, how can we reuse a previously computed palindrome to compute a larger palindrome? But then I will tell you later about this one. And the hint number 2 right here, if ABA is a palindrome and is XABAX is also a palindrome, similarly is XABA and Y is also a palindrome or not. Since this one is not a palindrome, then of course we are only counting this one. But then again, this A, B, and A is also considered a palindrome. So that is a thing that needs to be considered as we solve this code. And for this hint number 3 right here, we have complexity based hint. If we use brute force, check whether for every start and end position a substring is a palindrome, we have 0, and with the power of 2, which is the complexity of quadratic complexity, and the end person with the logarithmic palindromic check, can we reduce the time for palindromic check to linear time by reusing some previous computation. And for this hint number 3 and hint number 1 is they are both related to each other to solve this code. But for this video, I'm going to use more simpler approach instead of using the most complicated to write code, even if it's the real answer to solve the complexity, to avoid this quadratic complexity. And I'm going to balance between complexity and also the complexity of the writing the code itself. Okay, so but the first one, we need to solve this by creating a variable called the let palindrome and takes an empty string. And for this return, since it is expecting a string, then of course we can return our palindrome. And between the variable and the return statement, of course we need to iterate over the string. I'm using my own approach by iterating the string itself one by one, and then expand the string to check if it's palindrome, and then checking for another substring if it is palindrome started from the index from the string using the for loop, or let I equals to 0 from the start index of the string, as long as I is below the s with the property of length. Then of course we use the I++, and then inside the for loop right here, we can declare our let variable let temporary, and we can use this temporary using a function to calculate which substring is returning palindrome or not, and then we can store this as our temporary palindrome string and check if it is nominated as the return statement right here. So to visualize this, I'm going to use a standard approach using the comment. We can check if the B, A, B, N, and D, and we are checking from the index 0 right here, since we are starting from the using the for loop right here, index 0, B, and then we can expand D from the B to check if the A to the right and checking to the left. Since left is null or it is out of bound from the index 0, of course we are only returning the B. And also the same thing goes to check if it is an even palindrome substring. Check if B using the A right here, X expands using two pointers using the B and A, but using the I as the reference point, and then using I plus 1, which is the A right here, check if B and A is palindrome. Since it's not, then of course we are iterating over the for loop, next iteration, checking A with the B right here. Since they are not a palindrome, then of course we are checking the B, pointing the I to the index number 2, and checking using the expand, check if it's A is also a palindrome. Since it's not, then of course we are going to iterate the A, check if it's D. Since it's not, then of course we are stopping the iteration because it already hits the end of the S string of the length, and we can adjust for the edge case to see if it's going to iterate out of bound from the length right here, as we expand our string to check if it's palindrome or not. And then we can, if it's a palindrome, then we can store it as the temporary palindrome variable. And since we are using the odd check, we have two modes of check. We can use the odd one, we can use the even one. Even one is checking, let's say we have the A, B, B, and A. This is for the even one. And then A using against the B right here, we have we only returning a temporary value of none or just empty string, I believe, or just the A, either B, I don't know. But then if it's checking again, if it's B as D from the current index expands, then checking for the both of the B's right here. Since they are palindromic, then of course we are going to move the left pointer to subtract it by 1 to the left, in other words, and the right pointer to the right, and then checking both A are equals from the set index of the expansion if it is a palindrome, and then checking again for the next one, since next one is already null or out of bound from the index limit of the left and index limit of the right using the substring, current substring. Then of course we are returning the whole string right here as our palindromic result inside the temporary variable right here. And then the temporary will be compared against the odd check. If we have the odd check, let's say if we have A, B, and A right here, okay, not A, B, and A, but the odd check is checking A and then expands to the right with B and expands to the left, which is none. And then since it is already limited or only returning A, then of course A is not nominated other than the A, B, B, and A. And then continue again with the odd operation, B right here, using the A, check against the B right here, since A and B is not a palindrome, which is the A, B, and B right here. Then of course it is going to skip the for loop and checking for the next one, and this one is also not a palindrome. Then of course for the last one, it is also not a palindrome. Then the iteration will stop and the temporary will return only one word, either A or B, and then comparing against the even check, because even is already returning the full string. Then of course this even check will return as the current palindrome, and the palindrome will be returned as our answer. And for this first one right here, it's only applied for the odd check, and for this one right here it is applied for the even check. So to do this, we can simply declare our function. For the first one, don't forget to mark this one. We can use the odd check, and for the next one is the even check, and this operation is still inside the for loop. It is because we are checking every string, and as we check every string, we expand over the right and left, and also the same thing goes to the even check to the left and also to the right, and that way we are aware of the possible outcome of every substring. And then we can add a function called the function. I'm using the function, not using the arrow function, because I'm just doing it for the I'm just aligning as the longest palindrome function right here. So I will be doing the same thing using the function expand, and we take the string itself in the string, and then since we are working with the TypeScript, then of course we are using the type of the string right here, marked with the number marked with the green color after the colon sign, and then the next parameter, which is the left pointer, and this one is going to move to the left, and it is in the form of integer or number because we are working with TypeScript. And the next one is the right pointer, and also it is the third type of the number, and the expected output from the expand function will be a string, just like the one from the longest palindrome function. And we can simply return the string, but before that we need to check if, as I said earlier from this raw visualization, check if it is not currently in the limit of the index checking, and both right and left are still the same using the index. If it's the same, then it will continue expanding. That if it's not, then of course we will stop the expansion and return the current index from the left and right by using the while loop. While check if the left index is still higher or equal to the index of the left limiter. Since the left limit is 0, then of course we are assigning 0. And also check if the right pointer is still pointing inside the string.length, and this part acts as the limiter to check if the expansion hits the right or left limit of the string that we are trying to work. And for the next check, we can simply declare another parenthesis and an operator check, and if the string using the left index is strictly equals to the string of the right index, as long as it is the left and index is still the same, then of course we are going to using these parentheses, curly brackets, I'm sorry, it is curly brackets, then we are moving the left by 1 and also the right by 1. And for the return statement, we can simply return the string using the substring and takes the left and with the right. But then let me tell you something about this string operation using the substring operation inside the MDN docs of the JavaScript documentation. This is the official documentation of MDN docs. Let's say we have the substring of the first parameter, which is 1, and the second parameter, which is 3. Let's run this. We are pointing the 1, which is inclusive. Why is it inclusive? Because index 1 is correctly pointing to the O right here, which is addressed as the output as the O and Z. And for this 3 right here, as the second parameter, 3 is pointing to the 0, 1, 2, and 3, which is the I right here. And then I, too bad that I is not being registered as the substring operation. It is because the second parameter, it's excluded from the index, which is the I right here. It is excluded from the returning substring method right here. To get around this, you might want to use using the +1 right here, and then assigning the I as our returning 1, using the shifted by 1 in order to return the I right here. But then that will be the wrong one, because if we happen to, let's say we are iterating the I right here. Let's say we have the palindrome of A, B, and D. And then if we want to return the A, B, and A, of course we are using the 1 and 0, 1, 2, 3, and 4. Using the 4, returning A, B, and A. Since it is true, but then it is not entirely true. What about if we are using this B right here, which is the index 2, and also using the index 2 as our substring check from this expand function right here that takes the left and right parameter? Since the temporary, we'll use the expand function. We'll be calling the expand function with the passing the string as the first parameter that accepts as the string right here. Using the string parameter, passes on, and then for the second parameter that takes the I, and then the third parameter, which is also the I right here. Using the expansion, since we are using the out check, then of course we are starting from the 1 point only, and this one is going to move to the left and this one is going to move to the right, and checking if both left and right pointer or the index is still the same or not. Since A and A is still the same, then of course it is correct in out check operation. And also the same thing goes to even check. If the B and also B is correct, then it is also considered an even check using the temporary, and then using the expand, using the S, I, and I plus 1. That is the small difference between using the out check and the even check using the expand function that we already created. To get around this, instead of using the 2 and 2 right here for the out check, let me rename this to out check. If we happen to use the 2 and 2, then we will return an empty string, and that way we are not returning anything from the expand function. But palindrome, even if it's one word, it is also considered, or one letter, it is also still considered as the palindrome. So in order to get around this empty string from the substring right here, of course we are going to, since the first parameter is inclusive and the second parameter is going to be the index points, but it is excluded from the output from the substring method, then of course we are going to get around this by using the I plus 1, using the live pointer by 1, and that way we are returning B as the answer, even though we are not returning anything from the out check. And the same thing also goes to the even check. Let's say if we have the, for the out check, let me use the, let's say if we only returning B, how about we are returning the AB and ABA from the expand function? We are subtracting the left pointer by 1 and adding the right pointer by 1, so it is pointing to the 1 plus 1 and 3. And if we run this, we still got the B right here. What about we are using the 0 and then using the 4? We got the A, B, and A. Okay, so for the first initialization of the expand function, we'll still return a word even though if the palindrome is not found within that word itself from the string parameter of the first parameter of the expand function. And for this even check, we can use the second even check in the A, B, B, and A. Let's say if we use the index 1 and then the next one will be also index 1. If we run this, we got the empty string. What happened if we are adding by 1 and we still got the B, since we are working with the even index or even check of the palindrome checker? Then the A, B, B, and A is palindrome, and the middle point is the empty space between the B and B, both B's right here. Then the middle check will also add by 1. If we run this, we got the empty string. What about we decrease this one and we increase this one thing too? If we run this, we got VB. What if we increase this one again, -1, and this one is going to be 3, and we got the ABBA. So it is complicated than then it already is, because the way I explain it is not understandable for people or my audience. Okay, so let's go back to our code, and we can add the check if, for the auth check right here, if the temporary length using the length property is higher than the palindrome.length. If it is, then of course we are assigning the palindrome with the temporary string. And for the next one, it is also the same thing, goes to the event check, but the main difference is by using the +1 as the addition from the second parameter or from the third parameter. Okay, so let's run this to see if it works. We have the wrong answer, and the expected output is B, A, and B, but then we got B, A, B, and A. So this one is important by using the +1 from the substring return statement of the string, using the left +1 and right is as it is. Okay, so let's run this again to see if it works. Accepted. Let me decrease the size so you can see better of our code. Okay, so let's run this using the Control Enter to see the result, and we have the runtime of 19 milliseconds, I'm sorry, and the memory complexity of the 59 megabyte. And about from the start, let me tell you something about the algorithm. From the hint right here, we have the hint 1 and the hint 3. It is related to the one algorithm name called the Manasher algorithm. It's called the Manasher algorithm. You can look it up on Google or YouTube if you want. There is one way to solve it by creating a complex coding, but as the output will be returning as the more simple runtime than the one I already proposed right here from my code. Okay, so that's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section, or if you have any better solutions regarding this challenge, tell us what you think in the comment section. I hope you have a great day. Thank you for watching the video, and I will see you in the next video. Goodbye.